Rhino 3D and Grasshopper Example 1. For this example, I used two sine curves sine x and sine 2x for top chord and bottom chord of truss structure from 0 to 180 degree. Here are grasshopper expression function sine x for top chord and sine 2x for bottom chord. Using loft function, we can create a surface with two curves. To make truss frame, I used a lunchbox plugin command 2D truss. Top chord and bottom chord curves are used in curve A and curve B to form truss frame. Division allows to define the number of panel points along the length. Once one truss is created, it can be copied as many you want and in any distance. I made two groups, one for chords, the other for web members. For 3D extrusion view, we can use pipe command with diameter. It will give an idea how structural will look in reality. Now let's transfer these reference lines to SAP 2000. First of all, I bake chords, web, members and beams, and export these lines to IGS file. Open the SAP 2000, make sure use consistent unit, import IGS file. Once the reference lines are imported, the real workflow in SAP 2000 begins. Start by assigning the boundary conditions. This defines how your structure interacts with its supports and the ground, whether it's fixed, pinned, or on rollers. Next, define your material properties. Choose the material type, whether it's concrete, steel, or something else, and assign preliminary section sizes that suit your design intent. With those in place, run a quick test analysis under the default dead load. This initial run helps verify that your setup is working properly and that there are no critical errors in the model. Throughout this process, practice using SAP 2000's tools and commands. The more familiar you become, the more efficiently you'll work. Remember, practice isn't just repetition. It's the path that leads you to where you want to be.